On a gray October morning in 2023, 5 beavers were loaded into wooden crates and driven along winding Welsh lanes toward a stretch of wetland that had been quietly dying for decades. Nobody filmed a dramatic release. Nobody stood at a podium. A gate was opened, the crates were set down in the reeds, and the animals stepped out into a landscape they had not occupied for 400 years. The people who arranged all of this were cautiously hopeful. 5 animals is a nerve-wracking number. One territorial dispute, one harsh winter, one outbreak of disease, and the entire project could fold before it had properly begun. But cautious hope was not what this story delivered. What the wetland delivered instead was something the monitoring teams, the ecologists, the bat surveyors, the dragonfly counters, and even the farmers downstream had not dared to fully predict. The river didn't just accept the beavers. It remembered them. And what it did next with that memory is what makes this one of the most striking ecological stories to come out of Britain in a generation. I am Lawson Gray, and this is the full arc of what happened when Wales gave a dying river back to the animal that built it. How beavers vanished from these valleys in the first place. Why it took nearly 20 years just to open that gate. What the science from comparable sites has already shown us, and why the Welsh government just made a decision that conservationists are calling a potential turning point for entire river catchments, not just a single species. To understand why that October morning mattered, you have to go back much further than the planning meetings and the license applications. You have to go back to a Wales that no longer exists in anyone's living memory. Picture a Wales where every lowland valley held slow-moving water in summer, where riverbanks were fringed with the stumps of coppiced willows chewed flat by the waterline, not by a chainsaw, but by incisors the color of rusted iron, where shallow ponds spread back from river channels into the floodplain, and where the hum of insects above those ponds was thick enough to feel against your skin. That Wales existed for thousands of years, and at the center of it, engineering all of it, gnawing it into shape and holding it in place with dams built from branches and mud, were beavers. Not as decoration, not as a charming addition to an otherwise functioning landscape, as the mechanism, as the architects of the whole system. The Eurasian beaver had been woven into these river valleys since the ice retreated. Welsh place names still carry quiet traces of them. Old county names, field boundaries, the names of streams in Powys and Ceredigion that translate, roughly, into words for flooded ground or water meadow. The language preserved what the landscape had forgotten, because by the time anyone was writing careful records of British wildlife, the beavers were already nearly gone. Hunters had found in them an almost perfect commercial target. Their dense underfur was among the finest waterproofing material available before synthetics, and the demand from the hat trade and the fur market was not small or occasional. It was industrial. Beaver fur was worth killing for across an entire continent. Beyond the pelt, there was the meat, the oil, and the castor glands, secretory organs that beavers used to mark their territory, and that medieval apothecaries found uses for that, ranged from the sensible to the deeply improbable. Every part of the animal had a price, and so every animal was hunted. By the end of the Middle Ages, the beaver was functionally extinct across Wales, and by the close of the 16th century, the last record of a wild beaver anywhere in Britain had been entered into history and then not entered again. The silence that followed was not absolute. The wetlands didn't vanish overnight, but without the animals that had maintained them, the slow unraveling began. Water moved faster. Floodplains dried at their edges. The ponds silted up or were drained deliberately to create farmland. And the particular tangled richness that beavers produce, those stacked habitats of open water and deadwood and half-drowned scrub and deep root channels, began to simplify into something tidier and much less alive. 400 years is a long time. Long enough for generations of farmers, ecologists, and planners to simply accept what the landscape looked like without beavers as the baseline. Long enough for the idea of bringing them back to seem eccentric or even dangerous when someone first raised it in a conservation meeting. The Welsh Beaver Project began seriously investigating the feasibility of a reintroduction in 2005. That is not a misprint. 2 decades of research, consultation, stakeholder engagement, environmental impact assessment, and political negotiation separated the first serious conversation from the morning that gate opened. 2 decades, and the opposition to the project during those years was not trivial or ignorant. Farmers whose land sat adjacent to potential release sites asked reasonable questions about flooding, about tree loss along riverbanks, about what would happen if the animals moved beyond any managed boundary. Fishermen raised concerns about what beaver dams might mean for migratory fish. These were not questions asked in bad faith. They were questions asked by people who worked the land and the water and who had not seen what happens when beavers return because nobody alive in Wales had. What eventually moved the project forward was partly the weight of evidence accumulating from trial reintroductions elsewhere in Britain, and partly a recognition of what the landscape was already losing without intervention. The site that was chosen for the initial licensed release, a nature reserve in Powys called Cor Dyfi, was not chosen arbitrarily. The reserve sits in the Dyfi Valley and holds within it something ecologically rare and increasingly threatened in Wales: a lowland raised bog. Raised bogs are among the most carbon-dense and biodiversity-rich habitats in the British Isles. They accumulate peat over centuries. They hold water like a sponge. They are home to species of plant and insect found almost nowhere else. And the one at Cors Dyfi was in trouble. Dense stands of willow and birch had been advancing across it for decades, drinking the water table down, drying out the sphagnum moss that makes a raised bog function, replacing wet, living peat with a thickening scrub that was both drier and significantly less diverse. Land managers had been fighting that encroachment by hand. They cut the willow. They dragged out the birch. They kept cutting. The willow kept growing back. It's the kind of management treadmill that exhausts both budget and staff, and it never quite wins. Natural resources. Wales granted Montgomeryshire Wildlife Trust the license to release up to 6 beavers into a 7-acre enclosure on the reserve. The logic was elegant in its simplicity. Beavers eat willow and birch, not occasionally, not as a supplement to their diet, but as the core of their food and the raw material of their construction work. Put a beaver in a stand of encroaching willow, and the willow doesn't grow back the same way. It gets coppiced to the waterline, dammed into channels, turned into flooded habitat instead of dry scrub. The animal doesn't just eat the problem, it engineers the solution. The first animals to arrive were brought from Scotland, an adult male and its offspring. They stepped into a valley that hadn't held their kind since the 17th century, and then the landscape, which had been slowly losing its argument with the scrub, got a new advocate. The speed of what happened next is the part that still surprises people who haven't been watching the data come in from other sites. Because Wales was not the only place running this experiment. In Devon, in Dorset, in parts of Scotland, licensed beaver reintroductions and carefully monitored trials had been generating numbers for years before the Welsh gate opened, and those numbers were startling. At one monitored site where beavers arrived in 2017, within just a few years, the animals had constructed 8 woody, leaky dams. Those dams created a cascade of new pond habitats and wetland margins where none had existed before. Brown trout in the pools directly downstream more than doubled in recorded size. Not in number, in individual size. The fish were feeding on a bloom of invertebrate life that the beaver-created habitat had made possible. At the same site, researchers logging wildlife recorded 11 species of foraging bat, 17 species of dragonfly and damselfly, and 3 additional mammal species that had not been recorded there before the beavers arrived. All of this in a short window of time, not decades, years. In Dorset, the numbers from one recovery zone became the kind of statistic that stops a meeting cold when someone reads it out. Bat activity in certain beaver-influenced corridors had increased by more than 1,000%. Not double, not triple, 1,000%. To understand what that number is actually measuring, you have to follow the chain. Beavers slow water. Slowed water creates pools and backwaters. Pools and backwaters warm in the sun and grow rich with aquatic plants. Those plants become habitat for aquatic invertebrates. The invertebrates hatch as flying insects above the water surface, and bats, who navigate by the sound of insects in flight, converge on that abundance like a signal on a frequency. The beaver didn't set out to feed the bats. It set out to build a dam. The bats arrived because the chain of consequence ran all the way from a gnawed alder to the surface of a pond on a warm August evening. That is what an ecosystem engineer does. It doesn't just occupy a habitat, it manufactures one. The Devon beaver trial, one of the most closely watched of the British reintroductions, produced an evaluation that would have seemed ambitious as a projection before it ran. Within a few years of the beaver's return, researchers mapping the trial area documented a mosaic of wetlands and ponds, areas of standing dead wood and fallen timber, open grassland at the beaver-grazed margins, dense scrub zones, patches of sphagnum moss, and channels that hadn't held water in living memory filling and staying full. The species making use of all of this included dragonflies and butterflies, brown trout and Atlantic salmon, at least a dozen bat species, breeding birds, reptiles, and several amphibian species. A formal evaluation using a biodiversity quality calculator found that species richness had increased measurably, that the dominant species common across degraded habitats had become less overwhelmingly abundant, and that genuinely rare species had begun to appear in the record. Rare species don't arrive by accident. They arrive when the habitat they need exists. The beavers had rebuilt the habitat. None of this surprised the ecologists who had been arguing for reintroduction for years, but it arrived faster than almost anyone had formally predicted. And it raised a question that matters enormously for the rest of Britain, and for Wales in particular. If the animals can do this much this quickly in a managed enclosure, what could they do given a whole river catchment? The flood science is where the conversation changes register, because at a certain point, the bats and the dragonflies and the trout are an argument aimed at people who already care about biodiversity. The flood data is an argument aimed at everyone else. Research conducted at the University of Exeter on river systems with active beaver populations found that peak water flows, the surging volumes of water that fill rivers fastest after heavy rainfall and that break banks and inundate fields and wash out roads, were reduced by up to 24% downstream of beaver dams. 24% is not a rounding error in flood management. It is the difference between a road that stays passable and one that disappears under half a meter of water, between a farmyard that stays dry and one that needs shoveling out. But the more extraordinary finding was a different number. The lag time between peak rainfall and peak river flow, the delay between the sky emptying and the river responding, increased by 91% in beaver-influenced catchments. The water arrived. It just arrived much, much more slowly. Think about what a beaver dam actually is. It is not a solid wall. It is a leaky structure built from branches and mud that holds a body of water behind it, but allows water to percolate through continuously. When heavy rain falls, the water moving downstream hits the dam and spreads out into the pool behind it, and into the saturated ground surrounding that pool, and into the root systems of the wet-tolerant vegetation growing at its margins. The water is stored in the landscape itself rather than channeled through it. It seeps rather than surges. And when it eventually does reach the river proper, it arrives spread across hours or days rather than all at once. Every beaver pond in a catchment is a small break on the system. Stack 8 of them along a single stream and you have changed the hydrology of that entire valley. The same principle operates during drought. A study of a Canadian river system with active beaver populations found that beaver-influenced areas held 60% more open water during drought conditions compared to periods before the beavers returned. The ponds and saturated margins that fill in winter don't simply evaporate in summer, they hold. The water table in the land surrounding a beaver pond stays higher for longer. Vegetation that would otherwise die back in a dry spell keeps its root moisture. The landscape buffers itself against extremes of rainfall and of drought simultaneously, and it does this without any engineering infrastructure, without any maintenance budget, and without anyone checking in to make sure it's working. It works because the beaver keeps working. In Britain right now, only 14% of rivers are in anything approaching good ecological condition. Let that settle for a moment. 14%. The other 86% are compromised by some combination of physical modification, sediment loading, chemical pollution, or biological damage. Around 70% of the nitrate pollution entering British waterways arrives from agricultural runoff, fertilizer and slurry moving off fields in rainfall and draining through the soil into streams and rivers. Nitrate in waterways feeds algal blooms that deplete oxygen and choke out invertebrate life. It is one of the most pervasive and difficult problems in British freshwater conservation, and it is extremely difficult to address through conventional means because the source is diffuse, spread across an entire agricultural landscape rather than concentrated at a single pipe or outlet. Beaver ponds help. The slow water, the saturated margins, the dense root systems of the emergent vegetation that establishes around beaver-maintained wetlands, all of these act as biological filters, capturing sediment and processing nutrients before they reach the main river channel. Not perfectly, not completely, but measurably. For whales specifically, this matters in ways that go beyond abstract conservation targets. The country has committed to some of the most ambitious nature recovery goals in Britain. It also has a significant agricultural sector, a history of damaging flooding in lowland valleys, and a river network that has been structurally simplified over decades of drainage and flood defense engineering. Beavers are not a solution to all of those pressures simultaneously, but they are a single intervention that addresses several of them at once, without ongoing maintenance cost and without requiring farmers to stop farming. A 2022 study comparing 12 fenced beaver enclosures across England and Wales with matched control wetlands that held no beavers found that bat activity was significantly and consistently higher wherever beavers were present. Not slightly higher. Significantly higher across all 12 comparisons. This is the kind of result that moves a scientific consensus. It is not one site. It is not a lucky result from an unusually productive location. It is a pattern that repeats across a dozen different places, which means it is a pattern driven by the beavers themselves rather than by site-specific conditions. The mechanism is the same each time. The cascade from gnawed wood to flooded margin to emergent plant to invertebrate to bat, and it runs reliably because it is not a fragile chain. It is a robust one, built on relationships between species that evolved together across tens of thousands of years. The people who opposed the Welsh reintroduction were not wrong to ask hard questions. Some of the concerns raised by farmers and fishermen have required real attention during the trial years. Beaver dams can impede the movement of migratory fish if they are built across the main river channel rather than in side channels and tributaries, and this is something that requires monitoring and occasionally intervention. Beavers do fell trees along riverbanks, including trees that farmers would prefer to keep standing. The animals don't respect property boundaries. In a small, heavily managed agricultural landscape, that is a genuine complication. But what is striking about the conversations happening now, a few years into the Welsh trial, and a decade or more into the Devon and Scottish experiences, is how many of the farmers who began as skeptics have moved their position. Not because they were persuaded by a lecture on ecosystem services, but because they watched what happened downstream of beaver activity on their own land. They watched the flooding arrive later, or not at all. They watched dry ditches hold water into July. They watched the marsh at the bottom of the field become something alive again. The argument that convinced them was not an argument. It was an observation they made themselves. A survey conducted in Wales in 2023 found that nearly 90% of respondents supported returning wild beavers to the country, with more than 80% wanting those beavers to have strong legal protection. These are not numbers from a wildlife charity membership survey. They are from a general public poll, which means they include people with no prior connection to conservation. They include people who drive past fields, not through nature reserves. Public appetite for this was there, quiet and large, waiting for someone to act on it. In October 2025, the Welsh government committed to extending full legal protection to beavers across the entire country. And then in March 2026, that commitment became law. New Welsh legislation formally recognized the Eurasian beaver as a native species for the first time and granted it European protected species status. This means it is now illegal to deliberately harm a beaver in Wales. It is illegal to damage or destroy active beaver habitat. The animal has gone, in the space of a few years, from a species being cautiously trialed in a 7-acre enclosure to one with the strongest wildlife protections the law can offer. Conservationists called it a turning point, not just for the beaver, but for the whole philosophy of how Wales manages its river systems. Because the implications of that legal status are wide, protected species must be considered in planning decisions. Development that would degrade beaver habitat faces legal scrutiny. The presence of an active beaver lodge in a river catchment changes the legal landscape for everything built and farmed around it. The beavers at Cors Dyfi have not solved the problem of the encroaching birch and willow by themselves. No single intervention does that. But in the years since the gate opened, the monitoring teams visiting the site have recorded changes that the hand-clearing teams could not produce. The dam building has created the kind of waterlogged conditions that the raised bog needs to resist the scrub invasion, because willow and birch don't thrive in truly waterlogged ground the way that sphagnum does. The beavers have been doing what land managers had been trying to do with tools and labor, not instead of them, but as the ongoing maintenance engine that doesn't need a salary or a fuel budget. And as the population has grown and the animals have explored their enclosure, the catalog of species recorded in association with the site has grown with it in a way that tracks very closely with what the Devon and Dorset data had already predicted. There is a larger idea underneath all of this, and it is the one that makes the beaver story matter beyond the specific case of one wetland in Powys. The idea is this: that what we call ecological collapse is often not the permanent destruction of a system, but the removal of a process. The system is still there. The river is still there. The soil and the substrate and the rainfall and the geology that built the wetland over thousands of years, none of that has gone anywhere. What has gone is the thing that maintained the processes that made all of it function. Put the process back. Return the animal that ran it. Step back. And the system does not need to be rebuilt. It remembers how to build itself. That is not a romantic idea dressed up as science. The data from Devon, Dorset, Scotland, and now Wales supports it in concrete and measurable terms. Species counts, flood lag times, water table depths, bat transects, dragonfly surveys, trout sizes. These are not impressions. They are numbers logged in field notebooks by people who started the work as skeptics and ended it, in many cases, shaking their heads at how fast the land responded to being given its engineers back. 400 years is a long silence, and silences that long can feel permanent until something breaks them. 5 animals in wooden crates, driven along Welsh lanes on a gray morning, opened a gate that had been closed since the 16th century. The river on the other side of that gate had been waiting, in its patient way, for exactly this. And when the beavers stepped out into the reeds, the wetland that had been losing its argument with the scrub for decades quietly began to win it. The question I want to leave you with is this: if you live near a river, any river, and you know it isn't in the shape it once was, do you think a project like this one should be happening at your watershed? Leave your answer below. I read every one of them. If this story found you, share it, because the people making decisions about these landscapes need to know that the public is paying attention. There are more of these comebacks happening than most people realize, and I will keep bringing you every one that matters. I am Lawson Gray. Thank you for watching.